Hey guys, good evening. It's Rob from Opus. How is everybody doing? We're here to discuss FCA multi-air engines, and hope you guys learned something from it. Hope I can teach you guys something about it. And yeah, so that's that. That's what we're here for. All right. So what is multi-air? Why did Fiat develop this? It's essentially um, a way of controlling intake valves to basically have like a variable camshaft, if you would. We can control duration, we can control valve lift, we can control if we're going to open a valve, if we're not going to open a valve. Um, it's very similar to BMW Valtronic systems, and there's a few engines that it's currently used on, which would be the 1.4 liters, the 1.4 turbo, the 2-liter turbo in the Alfa Romeos, the 2.4 liter, and everything else. So it has a couple of benefits to it. One is slightly better fuel mileage, make a more efficient, cleaner running engine is the whole premise behind it. The added benefit is increase in horsepower. The increase in horsepower comes from what we can actually do to the intake valves without the restriction of a physical camshaft, in that we can have a bigger cam duration, or we can have more valve overlap for higher boost applications. So in some ways, that's really pretty cool in what you can do with it. I've seen some guys make some really crazy horsepower numbers out of these little engines. So here we have basically the 1.4, and there was a concept of them building a 3.6 liter Pentastar version. Now they were going to call it something else. I don't remember what the name was, but it never made it into production. So the variable valve actuator. What's circled right here is actually the intake cam, or what would be the intake valve cam lobes on the exhaust cam. The things back behind it are the cam followers and rockers actuating on the solenoid valve itself. Basically, it's like a hydraulic valve that's going to push against the intake valves when it's opening. Physically, the 2.4, 2-liter, and 1.4 available valve actuators all basically look the same. They all function the same, but they are different between the three engines, actually four engines, because, yeah. Oh, three. Yeah, there's one other. I forgot which one it is. It's a fairly new one. I think it's for the 1.3-liter engine, which is a fairly new engine, just coming to U.S. market. Not in very many vehicles. I think it's only used in the Jeep Renegade and Fiat 500X. So there is a special tool that's recommended to be used for removing a variable valve actuator or reinstalling a variable valve actuator. And what the tool does is it compresses the cam followers, so you can get the valve actuator, or as we call them at the dealership, the brick, in and out of the cylinder head with minimal force against the cam or unnecessary loading on the intake valves. It can A variable valve actuator can be installed without the tool, but it is a little tricky, and some guys I've heard in the field have accidentally bent intake valves, but it can be done without the tool. So components of the variable valve actuator are the pumping elements, which in this illustration is the upper. If you take one apart, I wish I had one taken apart at the time of doing this, but we have the solenoid, which is call out number one, the lash adjuster or rocker, um, call out number three, the accumulators, so that way we always have oil in it unless it sits for a long period of time. and the upper pumping element or chamber, which is the actual part that pushes on the intake valve in the cylinder head. Operation, basically, as we fill the solenoid with oil with pressurized oil from the oil pump, and we're commanding the solenoid to open the valve. We'll fill the chamber. When the rocker pushes against the valve tip on the actuator, it'll push the valve open at the same time. Now, if we don't want to open it, we just won't open the solenoids. We won't fill the chamber with oil. It is essentially how the system works in its basic functions. Feel free to take a screenshot if you want of what's on the screen, because my philosophy is if you know how something works, it's easier to fix it. So the four modes of operation are full valve lift, which is basically, we need all the power we can get, early intake valve closing, late intake valve closing, or we just leave it closed. The only time we really leave it closed, and this has gotten them in trouble on the 2.4 liter, is on D-cell. And where they got themselves in trouble is it creates too much of a vacuum in the cylinder, and it was starving the cylinder walls of oil, and it's created a oil consumption issue on the 2.4 liter engine. Oh, God, it's hot in here. So for early intake valve opening or closing rather, we're doing that more for fuel emissions, fuel economy and emissions. So full valve lift, variable valve actuator functions in all phases of the cam lobe. So as the cam lobe is engaged on the cam follower, whatever the profile of the camshaft is, that's what we're going to get as far as intake valve lift and duration. Early intake valve closing, basically we turn off the intake valve solenoid sooner, and we don't allow the cam to reach full lift. We don't open the intake valve fully, and we basically shut the cylinder off at that point, thereby increasing volumetric efficiency at lower RPMs. Basically, think of it as duty cycled intake valve, if you would, in a way. Late intake valve opening. So if we just need a little power, we can vary how much we're going to open the intake valve. Again, it's done for fuel mileage and supposed to help with emissions. Also can be used to simulate an EGR valve function, which most of the multi-air engines do not have EGR valves. So they are basically like electronic or programmed EGR valves. So during the closed phase, basically, we're not opening the valve. We don't want any power produced by that cylinder, so the intake valve stays closed. We don't open the solenoids. We don't do anything with the solenoid. It basically stays closed. So as the engine's running, the exhaust valves are still actuating because everything's driven off the exhaust camshaft. So if you look at a camshaft on a 1.4 or a 2.4 liter engine, they have 3 cam lobes per section of the cam for each cylinder. 2 of them are for the exhaust cam and for the exhaust valves. The center one is actually for the intake valves. These engines are 4 valves per cylinder, so we only need 1 lobe to actuate against the variable valve actuator to open the 2 intake valves. So the breakdown of the VVA, basically the parts of the variable valve actuator, the pumping elements, the solenoid valves, it's basically 2 parts, right? So as the cam follower pushes on the rocker and pushes against the variable valve actuator, we're basically pumping the chamber inside the variable valve actuator. That pumping effect is going to push against the solenoids and create higher pressure on the solenoid, so that when we open them, we push the pistons under the solenoids down, which opens the intake valves at that point. hydraulic brake actuator element. Basically, it's just I kind of explained it before, but it's the transition from like a horizontal piston to a vertical piston to act against the intake valves inside the variable valve actuator. Um, and it's also what allows us to vent the cylinder to allow the intake valves to close. So by how much we're opening and closing, we can control how fast the intake valve actually opens or closes. So differences between the engines. So basically the 1.4, 2 liter, and 2.4 liter, they're all essentially the same in some aspects. The real difference is with the 2 liter engine. The 2 liter engine is a gas direct injected engine. So the camshaft on the 2 liter is going to have an additional part that the other engines don't have. And that additional part is actually to drive the high pressure oil pump. The 1.4 liter engine, I mean, I used to have a car with one, and I did have a 1.4 turbo in the Dart that my wife used to have. Engine wise, it was a great car, made plenty of power. Always thought there was more it could do. The GDI engine is also the only one. Actually, no, I forgot. The 2015, 2016 Chrysler 200 also uses a mass airflow sensor on them. So they're kind of unique in how they operate because they will change the operation of the intake cam in accordance to what the mass airflow is reading. With the GDI, it's a little more controlled because we're basically making a lot more power with the GDI engine compared to the naturally aspirated 2.4 liter and 1.4 turbo. But the only vehicle that uses the 2 liter turbo with the multi-air is the Alfa Romeo brand. It's not in any Chrysler. The 2 liter gas directed injected in a Jeep is a traditional camshaft. There's no multi-air on that engine. Basically, the 2.4 has been around for quite a few years. In its previous version, it was basically twin cam variable valve timing world engine, which was developed during the Daimler Chrysler days, and it can be found in a bunch of other products, including, if I remember correctly, I think Minis had them in some markets, and Hyundai Kia used it in some of their products as well. Right. Does anybody have any questions? If you do, please submit them in the chat box. Or you can always email me a question if you have questions on it, or any webinar questions. You could email Brandon, who runs most of our training programs. We do also have a Jaguar Land Rover course coming up in August. I thought I saved it. But um, yes, they are controlling EGR through valve overlap with the um, how it's going to open the intake valve in relationship to the exhaust cam. So that's when we go into early intake valve opening, early intake valve closing elements. And someone else has a question here. So these things were built primarily, most of them used the Daimler Chrysler GPEC engine controller. Our wrap department can program them with very few issues. Seen any misfire failures? Yes. Misfires can be quite interesting with a multi-air engine because you can add it adds a third element into the misfire equation. So typically misfires are fuel related or spark related, but now on a multi-air engine, if we have a intake valve solenoid that's not working properly, or it's working but bleeding internally, we're not opening the intake valve, so it adds a third element to if we have a misfire or not. Um, Basically, when diagnosing them, if we don't have a solenoid valve fault code, which they do set fault codes for failed solenoids, what it'll do is it'll act like it's working, right? Solenoid's clicking and doing what it should, but it's just not opening the valve because it's bleeding off pressure internally. At that point, we don't open the intake valves, hence we got a misfire. One of the telltale signs if it's a variable valve actuator failure is we have no compression in that cylinder. Another thing that happens with them too is good question. As far as misfires go, it's kind of tricky because the PCM is directly controlling it. It's controlling the power to the solenoid. It's controlling the ground. So it's kind of tricky even to look at them on a scope. Sometimes the scope patterns can look a little weird. Sometimes if we connect the scope to them, it looks like the power is inverted with the ground, but it's just the way the module is controlling it. As far as maintenance goes, oh God. All right, so maintenance is critical with them. If you're not maintaining if your customer's not maintaining their vehicle properly, and we're getting any buildup of dirt in the oil, it will build up inside the multi-air unit. It will hang up the solenoids. It will cause all sorts of um, delayed intake valve opening when it shouldn't be. It could also prevent intake valves from closing fully. I've seen that. Oil specs are these engines do require a full synthetic oil, especially on the GDI engines. That's the one that's most critical because of the pressures that the fuel system itself is working on. It's not really because of the multi-air unit, but the multi-air unit adds another element as to why maintenance is so important on these cars. The manufacturer, like with my Dart, it basically had an oil change reminder. It wanted an oil change done almost every 10,000 miles. I never actually went by that. It would change the oil every 6,000 miles. It just made more sense. Just knowing how critical oil is with them. That's also, so that brings up another topic with these things. What brings on the stall? So if you ever had a Chrysler Jeep product with a 2.4 liter in it, customer complains of an intermittent stalling issue. I kind of started on that, and I should have went a little further on it in the initial discussion on the engines, um, and where I said the closed intake valve closed mode is what got them in some trouble with some engines, more specifically the 2.4 liter. With the 2.4 liter, there's actually a recall on them for oil consumption. And during a decel situation where the throttle body is closed, the intake valves are closed, um, there's such a vacuum inside the cylinder, it's actually pulling the oil off the sides of the cylinder walls and causing basically the engine to self-destruct from the inside out. As far as using, well, let me finish with the what brings the stall is when as the cylinder walls wear, it's just going to start sucking its oil out of its crankcase. And once we lose oil pressure, we no longer have the ability to open the intake valves. As far as using any oil additives to clean up buildup in the multi-air unit, As far as using any additives from like BG or Justice Brothers or anything like that, um, manufacturer says no, you're not supposed to. But let's be real. We live in a real world, right? So we want to try to make these things live as long as possible. I've worked at dealers where we use BG products. I've worked and we've also used Justice Brother products, Valvoline products, whatever. Um, as long as you're doing the in basically like an internal engine cleaning properly, allowing the solutions to work, and good at following up with a good quality oil, and the engine's not too far gone as far as being beyond its maintenance recommendations, it should be able to clean it out. It's kind of hard to tell because it's not like we can actually go in there and see what's going on. Yes, you can take a variable valve actuator apart. They're not that hard to take apart. Um, but yeah, it's just like any other thing. It's if you think about it, with how small the passages are inside, it's like the valve body of a transmission. So if we have a way of cleaning debris out of that, it's essentially the same concept. So I don't see a problem with trying to clean them with anything. It all depends on how far, how much dirt's actually built up inside of it, basically. Um, I've only ever seen one multi-air engine when I took the valve cover off that was actually full of sludge, and at that point, I was like, no, we're not even going to try to save this thing because it was just too far gone. I mean, I couldn't even see the exhaust valves. It was so bad. As far as engine calibrations, all right, so what I'm thinking is you're asking about the calibrations with the early 2.4s like 2015, 2016 Jeep Compass Patriots, where if you reflash the engine controller, there's a chance the vehicle will not start because an engine has been replaced at some point. That's not a problem with these engines. They're not that specific. The the early 2.4, the World engine, is a little different in some relations. But basically a 2.4 out of a Dart can go into a two-wheel drive Jeep Cherokee without any issues. The issue with the earlier engine was depending on they made some changes. I don't know what the changes were, but there was a TSB from Chrysler about that too. It was basically, look, make sure this is the original engine in this car before you do this update. If not, there's a chance it will not start. And at that point, the only way I know of would be to replace the engine if that's the case. Yeah. That so someone's saying, they've been getting that $20 oil change with conventional oil. Um, yeah, conventional oils do not generally work well with the pressure that's inside that solenoid valve. Um, I've had people try, and those are the ones that usually come in with the misfires that don't make any sense, and some other running problems. Yes, it is a great little engine when it's well maintained. Yes, I will say that. Um, my neighbor down the block has a pretty nasty little 1.4 in his Fiat Abarth, and that thing is actually louder than my Mustang with straight pipes on my Mustang. Yeah, there's really no. All right, so the question is, are there any components that are serviceable inside the unit? Sounds like a brick replacement for any issue that crops up with it. Um, I don't know of any place that sells anything aside from upgraded valve springs for the performance guys. There may be people out there selling solenoids. I don't know. I haven't seen them. My personal experience is anytime there's a failure, it's a replacement part. So that's a good question. I'm actually I think maybe I'll start looking into that. You're very welcome. Like I said, I hope I can help you guys learn something about it, help understand how the engine works and all the inner parts of it. I mean, if I was still at a dealership, I probably had about 5 bricks I could have took apart for the class. Um, yeah, so any other questions? Well, it's not the exhaust lobe. All right, so the question is, are there any issues with the exhaust lobes driving the variable valve actuator? Um, the exhaust lobes only open the exhaust cam. I mean, the exhaust lobes only open the exhaust valves on the cylinder head. On the camshaft, there's a third lobe in between the two exhaust lobes. That third lobe is what rides against the cam follower for the variable valve actuator for the intake valve. So if you're looking at one of these camshafts, you'll say, wait a minute, it only has an exhaust cam, but why do I have three cam lobes? That third cam lobe in the center is actually for the intake valve. And we are having a Jaguar Land Rover fuel system webinar coming up in August. You can find that at opusivs.com, support training. And I believe Brandon has another class coming up too himself. Um, yeah, I'm not very familiar with the HEUI system. I don't know who uses that. I don't know what it's used in. I don't know the application on it. I only know about this system, and I only know how similar it is to the BMW Valvetronic because it's talking to the guys in the office whenever they're talking to a customer with a Valvetronic issue. I'm like, whoa, wait a minute, that kind of sounds like multi-air. So we started talking about it. I'm like, wow, okay, so Ford Navistar diesels, yeah. I'm not a very big fan of Ford diesels lately, but that's a story for another time. Diesel engines, Cat and Navistar. Okay. All right. So it's a concept used in more medium heavy duty world as well. Good to know. Good. See, you guys are teaching me too. That's awesome. Ejector operation is very similar. Okay. Yes, it is still being used. It is still in use on. All right. So the question is Chrysler still using these systems? We don't see many of these engines in my aftermarket shop. If you're working on any 2014 and later Jeep Cherokee, Dodge Darts, 2012 to 20, when did they get rid of them? 16, 17-ish, Dodge Darts, Chrysler 200s, Jeep Renegades, Fiat 500s, the 500, the little 500 non-turbo gets the 1.4 non-turbo. You could either be an 8 valve or a 16 valve. The 16 valve is the multi-air. I believe the 8 valve is has an intake cam. I have never honestly seen one of those myself. Basically, everyone I seen at the dealership was always a 16 valve engine. It's also used, as I said, in the current Alfa Romeo Giulia Stelvio, and I believe that the new Tonal, which is a hybrid. I'm not sure which version of this engine line it's being used in that, but yeah, pretty much any modern or 14 and later Fiat based Chrysler vehicle. So, like I said, Dodge Dart, Chrysler 200, uh, Jeep Cherokee, Renegade, 17 and later Compass, or the new body style Compass. So yeah, you may not notice them, but they are there. The other thing too, now that I'm thinking about it, a lot of customers used to come in and complain about how noisy these engines are. Yes, they are quite noisy, and the noise is because of the solenoids and the actuators working inside the variable valve actuator. A lot of people would really notice it if our lube techs would leave the engine covers off. The engine cover is a noise damper, so it is actually there for a reason. It's not just there to look good or give some give somebody something pretty to look at. So it is there to try to minimize NVH issues. That's a good question. How important is it to pre-fill the unit? I'll be honest with you. Fill it as much as you can. It's never going to be enough. It's still going to be um, a hard start. So generally, whenever replacing a unit, or how we would get a lot of cars towed in from like long-term storage at the airport, they would always come in as a crank no start, and sometimes the starter would be killed in it along with a dead battery. But if these engines sit for too long, they do lose their prime. So to get them to restart, if that's what we're thinking, what we usually do is we'll pull the spark plugs out of the engine, crank it for 2 to 3 engine cycles, put the spark plugs back in it, and try to start it again. Also, keep a battery charger on it. After every 2 to 3 crank cycle, let the starter cool off to prevent it from getting burned out. Yes, they do. All right, so this next question is, are they having issues with piston contact with the valves hanging open? So if they're hanging open due to lack of maintenance, usually it's very minimal amount that they're hanging open. Very, very small amount. If somebody had installed one and they hurried it and they bent the valve, yes, they will bend valves. Or if they force a intake valve to open when it shouldn't, yes, they are an interference engine. I've only ever seen that happen once. And if I didn't see the pictures or I didn't see the engine apart, I would not have believed it because I didn't think it was possible. But somebody, they were doing something they shouldn't have done, and they basically commanded the solenoids open and cranked it with the intake valves open and all the valves. So normal operation, if we're not doing anything crazy or anything like that, or a tuner's not trying to get more power out of one, no, they normally will not bend valves on their own. It's usually in because of somebody doing something electrically with them that they shouldn't have been doing, or somebody didn't walk the brick into place properly when replacing one without the tools. I know in the slide when we went to, let me go back to it. Bear with me here. Oh, there we go. That's what I want. When talking about the tool, so Freedom Racing, when they first came out with this tool, it was just about as expensive as the Chrysler part numbered tool. They have dropped their price on it significantly. So I would say check out their website. If you see a lot of these engines in your shop and you're doing a lot of variable valve actuator replacements, I would highly recommend it. It does make the job so much easier when you have that tool. Any other questions? Any any questions as far as what we can do? Oh man, I lost my train of thought. Yeah, so it's this mode that basically is the one I call the killer of cylinder walls, which at first when they came out with the recall for it, I didn't understand how a reflash was going to fix this issue. But that's what the fix was. Yes, they lose compression primarily because of damage from the completely closed phase. Uh, during decel events with the intake valves closed, the throttle body closed, it was creating too much of a vacuum inside the engine. And as the piston was traveling down the bore, it was pulling all the oil off the cylinder walls, basically starving the cylinder walls for oil. So yes, we did see pistons galling cylinders, cylinder walls that just it looks like somebody took a bunch of sand and just threw it inside of the engine. Yes, you can get. All right. So the question is it really just working as a variable valve function reduction? If you need full valve lift and duration, does the hydraulic you transmit the full cam profile to the valve? Yes, it does. Um, Basically, full lift is going to be we're opening the solenoids, allowing full oil pressure in there, open that intake valve up. As long as that cam has a lobe to it, it's going to stay open. The real benefits are what you could do at low RPM or as far as like valve overlap, um, creating you could basically build more boost by opening the intake valves at a slightly different time, and that's how some guys are getting some crazy horsepower numbers out of them. Yes, it will bleed pressure if it needs like so when it first opens it's going to basically start at full the intention of full valve lift, as I was explaining when I went to court to school on these engines. Um, so it really controls everything on once we start opening the valve, we'll start bleeding off pressure on how much we want to open and keep the valve open for. There is actually a partially open phase, but they don't use that very often. Um, that phase, they say, if it's not timed right, can cause irreversible damage, so to speak. Yeah, in a way, it's kind of like how Crossending does their pneumatic intake valves. And actually, I think they do the exhaust valves too. I mean, that's actually pretty amazing what they do using air pressure inside the cylinder head. I don't know. Air systems opens up more issues as far as experience tells me. Any other questions? Mm, Shoot me an email at robert.swain at Opus IVS, and I'll try to send you a PDF copy of it. Yeah, so anybody who wants a copy of it, yeah, just shoot me an email and we can get one out to you. You're very welcome. Yeah, like I said, just shoot me an email down at the question down at the bottom at robert.swain at opusivs.com. Even if you guys are working on one and you just have a question, um, you shoot me a question. I can try to help you as much as I can within the constraints of me still doing my job. And the biggest problem with these things is maintenance. Maintenance is critical with them. Well, all right. So the question is the production on these engines getting bigger in the Stellantis brands, or are they just not much popular worldwide? The technology actually is Fiat's technology. It was being used by Fiat globally before Fiat actually brought the technology here to the US under, well, when they brought Fiat back to the US, and they came out with the Dart and the 200 platforms. Alfa Romeo Giulietta, which is what the Jeep Cherokee is loosely based off of, along with the Dodge Dart. They used a 1.3, I think it was, version of this engine for years. Then they stepped it up to 1.4 that we see here in the States. As far as what they're actually doing in Europe, I'm not really sure. I don't really stay up on what Stellantis is doing globally right now. Um, yeah, especially don't know if they're integrating this into any of the Peugeot or Citroen products yet. There's another brand. I don't remember what it is though. But yeah, globally they've been around for a while with this technology. It's new to it, it was new technology to us in like 2012 on the Chrysler side. But as far as the Fiat side, I mean, Fiat's been using it for a few years. Once Fiat was buying out Chrysler, I started looking into it. I was like, wow, that's actually really neat what they do. And so when my wife wanted a new car and we bought her Dart, I was actually pretty excited about it because it had a multi-air engine in it. And I mean, I liked it. There were some things about the car I didn't like. Living here in New York, potholes, low profile tires, and cars with stiff suspensions. Yeah, replaced quite a few wheels and tires and struts. Oil viscosity, yeah. So will improper oil viscosity affect operation? In theory, it can. Have I actually seen it cause any real issues? Um, I'll say no. But like here in the environment I live in, uh, a 5W20, 5W30, there's not much difference between them. Now, if somebody puts 1040 or 2050 in one, it may have an effect. It may cause some weird things to happen. I just never seen it happen because I don't know. I just never seen it. Never seen the results of that. But I would imagine, yeah, that it would have some sort of adverse effect on how fast it'll allow the valve to open and close. I could definitely see that happening. I'm gonna hunt down a friend who still has one and see if I could fill his with 2050 and see what it does. Actually, no, I would actually never do that to a car. Um, Bad things can happen. One of the things we tried in my hot rod days to see what's going on. Yeah, guys, any other questions? So would thicker oil, all right, so would thicker oil change oil pressure in colder climates and cause poor circulation? Um, Pretty much, yeah, that's pretty much any engine if we're using the wrong oil viscosity for the climate, yes, it would definitely cause some sort of issues. I could definitely see it starving some parts of the engine for oil, just like any conventional engine would. Are the engines easy to make a tune-up or swap to compete at race or rally events? Um, yes, yeah. They can make some decent power for their size. Um, I'm not gonna lie, my former parts manager, his A Barth was pushing like 320 at the front wheels. I mean, when we're dealing with an engine that's only 1.4 liters, that was mostly through tuning. I know he had the upgraded valve springs on the variable valve actuator. Um, he actually had a different camshaft in it too, so that basically had a bigger cam. But yeah, he did a whole bunch of stuff to that thing, and it was a pretty nasty little Fiat. My neighbor down the block, he's like I said, he's got one that's louder than my Mustang. But yes, in Europe they do use these engines for racing and mostly rally racing. I mean, that's really big in Europe, right? So the Fiat Panda, I believe, is the rally car that they use most. I think there's an Alpha too. Um, if anybody's into IMSA racing, there, if you watch the Pilot Challenge, there's the lone um, Alfa Romeo that's a multi-air based engine. If I remember correctly, I seen it once at the New York Auto Show. Really neat little car. So transmissions, um, transmission choices on these things. So they depending on the chassis. So the Dart with the 1.4 liter, the Fiat 500, the Fiat 500X, I think it is. No, Fiat 500L. Um, with the 1.4, they both use a dual drive clutch transmission. Any of them can be had with the 6-speed manual transmission, the Fiat 6C635. Um, in the 200, the Jeep Cherokees and everything else, it's pretty much ZF 9-speed. Harley, thank you. Have a good evening yourself, and I hope I was able to enlighten you on the world of the multi-air engine. All right, guys. So once again, if anybody has any questions, feel free to send me an email. I'll do my best to get back to everybody. With that, I hope everybody has taken something away from this. I hope I helped you in some way. And we do have a Jaguar Land Rover fuel webinar coming up in August. Be sure to check that out on our website at opusivs.com. Uh, support training under the support tab under training. So with that, have a great night, everybody, and we'll do this